Greetings, globe heads and flurfers. Did you know that tomorrow is a very special opportunity for all of you flurfers to prove whether the Earth, prove once and for all whether the Earth is flat or is a globe? You see, tomorrow is the autumnal equinox. This is one of two times in the year when the sun's path is going to have it directly over the equator all the way around the globe. Now, or as you would say, maybe all the way around the disk, whatever. Now, listen, hear me out here. Imagine for a second that you are very near the equator. Imagine that you're very near the pole, the North Pole. And I realize there's no flat Earth model. And so, because of that, there's all these different ideas that flat earthers have, and no flat earther agrees on every single part of the thing. But most flat earthers will say that the Earth is a flat disk, that the center of that disk is the North Pole, and that the sun travels around in a circle above this flat disk centered around the North Pole. Most flat earthers believe that. So let me take you here for a moment and imagine that you are standing on a line of latitude that is just a few feet from the North Pole. Now, you've traveled a few feet from the North Pole. The North Pole, if you could measure it, there's a stick literally sticking out of the ground. You know exactly where the North Pole is. You're going to turn now and face the east. Now, when you're facing the east, the North Pole is going to be on your left side, right? South is going to be to your right. Now, walk around this circle, this imaginary line of latitude that you've drawn, and let's say it's 100 feet around. Walk around to the opposite side of it from where you started. Now, you're still facing east. The North Pole is still on your left. But compared to the other side where you were a moment ago, you're facing the opposite direction. Can we agree on that? It's a circle. You're on one side of the circle. You walk around a half circle. Now you're facing the opposite direction. But in both cases, you're facing east. This is because the line is a circle that goes around. Now, every single line of latitude is a circle. And in every single line of latitude, that same phenomenon happens. And this is going to be the same whether you're on a flat disk or on a globe. The line of latitude goes around in a circle. Now, the difference between a globe and a flat Earth is this: the equator. On the globe, and only on the globe, the equator is a perfectly straight line. Now, when I'm talking about a perfectly straight line, I mean as far as going left or right. Obviously, on a globe, it's going to go around the globe the other way, right? Okay, because of this, if I am north of the equator, let's say I'm on the 45th parallel, which if you want to know where that is, it cuts across just north of Salem, between Salem and Portland, Oregon. It crosses I-5 and it crosses across the United States. I think it goes through New York or somewhere along there. So the 45th parallel goes right across the northern part of the United States. Let's imagine that you're on the 45th parallel, which is the halfway point between the equator and the North Pole. Now, if you were to travel east and you were to go all the way around from, let's say you started just north of Salem, Oregon, I think that's called Kaiser, Woodburn, somewhere in there. in Oregon. You stayed right on that 45th parallel and you traveled all the way around the Earth. You would slowly, the entire trip, be making, if you were heading east, you'd slowly be making a gentle left turn the entire way around. This is true on a globe. This is true on a flat disk. I think we can all agree on that. However, when you look in a straight line and you're facing due east, you're not looking around a corner. We know light only curves under certain circumstances. Refraction is one of them. I'm not here to argue about refraction, but I think we can all agree that generally light travels in a straight line. And when you're looking at a straight line, you're looking straight. There's no curve to that. So if you were to look due east and see forever, eventually the point you're going to see is not going to be east. As you look out from that line of latitude in a straight line, that line of latitude is slowly curving off to the left. And if you're looking straight, your view is going to drift to the south of that line because your view is not curving off to the left. Right? Okay. If you were to travel, if you were to start off facing due east and you were to travel in a perfectly straight line, you're going to drift further and further south off that line of latitude. The only way you're going to stay traveling east is if you make that slow curve. And if you're traveling with a compass and you're traveling at sea or whatever, you're probably not even going to notice it because you're going to stay on that compass. And since the compass is always going to point toward magnetic north, every time you adjust to keep from drifting off that compass, you're going to be making that slow left-hand turn. Okay. Now, again, the equator is different because on a disk, it would curve like every other line. And on a globe, from left to right, it would be perfectly straight. Can we all agree on that? I mean, that's just geometry. Okay. Here's the thing about the equinox tomorrow. If you go outside on the equator tomorrow, what you will see is you will see the sun rise absolutely 100% exactly smack dab due east. And the sun will come up and track over your head in a perfectly straight line to pass at zenith, straight up. And 12 hours after it rose, minus a little bit because you got the width of the sun itself, but roughly 12 hours after it rose, the sun will set at absolutely smack dab due west. You will witness the sun travel in a straight line for 12 hours. Now, think about on your disk how it would work. Your sun would go in a complete circle every 24 hours. Mathematically, there is no situation whatsoever where a sun or anything can travel in a straight line for 12 hours while making a circle in 24. In fact, if you could track that even just for a few hours going straight, it's not traveling in a circle. Not only that, but the sun, it would be literally impossible for the sun to rise due east and set due west because you're watching it come around in a circle and you're seeing 12 hours of it, which means it should come in from your northeast and go around and go out to your northwest. Absolutely 100% has to happen that way on your flat disk. And this isn't just on the equator. On the equator is the only place you'll see the sun travel in a straight line like this, because if you're north of the equator like I am, I'm Houston, Texas, which I think is about the 30th parallel, something like that. At noon, the sun is to my south. If it's over the equator, I'm not at the equator, so it's going to be south of me at noon. So I'm not going to witness it travel in a straight line. But guess what? For all of us in this part of the world, we're going to see the sun rise due east and set due west. Not northeast and northwest, as it absolutely has to on a flat disk. Go out tomorrow. Take your compass, shoot an azimuth. Don't forget to adjust for the declination wherever you live. You know, the magnetic north is not exactly the same as due north. But you can look it up on the internet, and you can find out what the declination is for where you live. Go out with a compass, shoot that azimuth, and prove once and for all, if the sun rises due east and sets due west, it absolutely 100% factually cannot be a flat disk. It's not possible. Try it. Have a good evening.